Alright, for the sort of third part of the assignment, after we've looked at 5 different materials, compared those after we've looked at 3 different, sort of components, the third part of the assignment is looking at a assembly. So this is going to change our approach slightly. I mean, with sort of, single layer materials, we could just kind of swap them out and it's all good. With doing a complete assembly, it sort of changes quite a bit. So, all right, for the full building, we're going to do the full building assessment, or I mean, if you're savvy with the design options, this would save you some times. But we're just going to do full building assessment. I'm going to look at a wall. So, right, got to select all these, click apply. And I'm going to investigate this exterior insulation on masonry. So, I mean, very similarly to like we did before, I would go through and I would modify all these items, right? I would, get each one correct. I'm not going to spend time doing that. I'll change this one. And apply. And mortar type N, most likely. Again, if you're not familiar with how these assemblies work, just do a little bit of research so you can make educated estimates on what's happening. For example, with the reinforcements, I believe these walls are going to be reinforced, so I'm going to go with a 48-inch on the center. Yeah, so we do that. Oh, fields must be completed. Default building, and that's all good. I'm not sure what's giving me static. Default value. Oh, right, the joint size. Let's do that. Okay. Apply, and then I would go through and I would update each one of these components that are part of this assembly, this exterior wall assembly system. Now, this is going to differ on how we just sort of swapped materials out, because you're going to fill all of these in and then generate your report. Now, what you can also do, for example, this is a brick wall. It's lacking the shelf angles that would actually be part of the assembly. So I can right click and add accessory material, and I will call this shelf angle, and then I can add this in so it actually accounts for it in the life cycle assessment. Some metal, steel, yeah, go call it an angle. Default to building, right? So the takeoff method, I'm going to say by spacing, and so I believe that might not be the best. I could do by, if I do by volume, I could do a percentage, or if I do length, may work, but that's going to come. Yeah, I guess spacing would work the best. So if I do two-way spacing, yeah, one way, feet, say 3-4 feet. So hopefully that's spacing them vertically. Gotta verify the way some of these settings are working from time to time. Click save. And then my shelf angle is being accounted for in this sort of analysis. So you go through, update all these, which I'm just going to save some time, not do right at the moment, and then do your report and run it, right, for this initial wall. I assume by the process of the previous portions of this assignment, you know how to go through ports and everything, the expected building life. I put 60 years in as default. Realistically, it's probably something more like 30 or 40. If you want to be super accurate about this, you could do a little bit of historical research, looking at building life cycles and determine the average expected building use, which would be nice to know. And so there's that. I'm just gonna select cancel because what I want to show you is, right, so let's say this is all filled out. I ran my analysis. So then I would, if it was me, so I recommend doing this. So let me, sorry, I closed it too fast. So I'm doing this. Oh, click apply. Good on there. So I'm just going to select isolate and Revit view so I know what I'm dealing with. So then I would take one of these and I would just do edit, duplicate, and we'll just call this, I don't know, wall consideration 2. Again, this is using, you know, the design options. And then I would work up alternate wall, floor, roof system, whatever you're using. Just, you know, consider these different layers and modifying their thicknesses and materials. So for here, example, masonry. So this actually has exterior wall insulation. Instead of that, let's become interested in, I don't know, making it brick. I'm going to reduce the thickness by half. Yes, I'd still want that. But then what? Another interesting and really informative way to do this too is to try to build up systems that maintain the same R value. We can see that materials aren't set in this assembly, but we know how to do that from previous assignments. And so try to come up with 2 different assemblies that have the same R value, and then we can do a comparative life cycle analysis. But, you know, I'm just really interested in your sort of comparisons, using the BIM information and the plugin of Tally to make some sort of informative comparison. Some maybe common ways of doing comparisons is definitely switching out the facade material, but then also the sort of primary, not even the primary structure of the building, but the sort of primary structure that's the facade's attached to. So maybe comparing something like metal stud versus woods. Wood stud would be an option. Actually, in this situation, instead of doing concrete block, how about we do stud? So that's that. This sort of, you know, it just helps keep things organized by having them labeled correctly. So then, way to swap these out, I'm just gonna right click one, or click on one, right click, then select all instances, visible in project, or, okay, all instances in entire project. Okay, it's not cooperating with me. Okay, there we go. I could have, oh, I know why, because I already changed this one to the 2, but yeah, so I could just select all instances, visible in view, and then I could just change this, update this to my new family I created. Not really clear on where it went. So, yeah. Okay, so this is wall construction 2. That's why I named it in a very generic way. That's not incredibly useful. But then I can just, there it is, just there. Now that I have all that updated, I would come over here, I would refresh my tally, And then I would, yeah, see, so it automatically associated this. I would go through and see this change the stud layer, so then I would edit this. This is obviously a wood. So wood framing. I mean, there's all kinds of options. So for this too, I wanted to use the wood framing just to specifically demonstrate that I can do the spacing, right? And so I select the size, probably let's say 2x8, and then I can do one way, and then here I can actually set the spacing between studs, which really kind of matters when we're thinking about this. And so with this larger stud, I'm getting 16-inch on center. I can do 24 normally in most applications. Yeah, so then you would just go through and update your new family. I mean, I definitely recommend modifying a fair amount of these variables within the family, but I would say at minimum, you know, try looking at two different things. If nothing else, try looking at a difference in the framing system, and then also the sort of cladding if you're doing a facade wall. If you're doing a roof wall, I would look at a different sort of topping, maybe membrane finish if it's a flat roof, and versus an insulation type could be interesting. If you're doing a floor, I would look at the framing versus maybe the sheathing. There's all kinds of options. If you're not clear, you know, let me know on what needs to be done. But this is very similarly to what you did before. You're just, in this one, you're just comparing two different assemblies and doing an LCA based upon that. Then to do the final part of the exercise, I'm going to put these back to where they were. So they were this initial installation on masonry. And then I'm just going to hit reset so I get the whole building. Huh. Always fun. Always fun with Revit. Okay, looks like we're going to deal with a minor crash here. Maybe. Maybe not. But the last part of the assignment, after you do that, you know, assembly comparison, is go through, because you've worked up to it, and okay, yeah, there's there, it's not letting me. Okay. You're going to go through and specify materials for every part of your building, and you're going to do a whole building life cycle analysis. Now, it may seem like a lot of information, but you can actually save a lot of time with the proper application of Tally. So let me give you an example by changing this glass, this glazing system. If I click apply, then I can, you know, pick all this out. Again, just default values. But I could see how I can check all these. So you want to be aware of what's getting applied, but generally we can kind of blanket apply things, and it just saves a lot of time. And so when you get done with this, you will, all of these dots should be green, because yellow tells you that something is kind of partially filled out, and green tells you that it's completely filled out. And so that's what you'll do, and just try to use materials that were maybe thought about or considered in the initial case study design of the project as you did it, because that's what we want, is a report on just the complete thing. So for this segment of the assignment, I went over how to compare two assemblies and what's required for that. I think explaining what needs to be done for the whole building life cycle analysis is self-evident. I mean, you're just going to go through here one by one and fill out every material. And I would say if you have enough knowledge about building systems, building construction systems, or made the effort to maybe educate yourself on what's missing within the family, then definitely add the accessory where warranted. I mean, this is just going to help the sort of reality of the analysis that you're creating, and if anything, benefit you. So you have a more realistic take on what's happened in your life cycle analysis and how your building relates to sort of ecological and environmental concerns. So, yes, I think that does it. Let me know if there's any questions. I'm here to help, for anything at all. So please reach out to me if anything's unclear, or you're just maybe stuck on some portion of the assignment, or even if you just want to have a chat about life cycle analysis and, really work on maybe understanding what's being done in the analysis more thoroughly. I mean, there's a lot of the assumptions that we're just kind of taking at face value that I've sort of avoided really going into detail about. I provided summary, but the reason I kind of avoided, because I don't want us to be kind of distracted on the accuracy of the life cycle analysis, but more on just how does it get applied and how does it interact with the BIM environment, because that's what we're sort of thinking about in this class, is how does BIM lend for these sort of on-demand insight into the decision-making process. But I'd be more than happy to go into more explicit detail of LCA and kind of what's happening behind the scenes and how to make one's reports just refined. I mean, that's what it's about, really, is about refinement. So it's not so much about inaccuracy versus accuracy, but just refinement. And most of these analysts are about that I'm requesting from you are about making comparisons, and that's the idea, is how do we generally make a better decision about the material we may be considering. So there you have it. I guess another thing I didn't go over is just a sort of display. You can do the units in imperial or metric. The Revit versus Tally, it can show you. So I just do use Revit materials, but you can toggle to using to viewing just sort of Tally specific materials. These would be new ones that were created or don't have a clear name to them. You can set a dummy material for just whatever, for something that basically has no real input, but you may want the area of. These sort of features across the top, I personally don't find them too valuable. They just function as filters, as you can see, but maybe you'll find them useful for your work. And I think that covers everything. Just again, just let me know if anything I could do to help your education, especially when it comes to LCA, because it's very serious, and we just don't understand how our building is really sort of damaging the earth without the sort of LCA information. In my opinion, we should be working towards carbon reduction, and we can do that more easily with BIM. So, okay, great. Good luck on everything, and take care.